I saw the Chromebooks yesterday. At our staff meeting, we got to use it and try it out. So you get them on Friday. They have one with everybody's name on it. Woo woo. All right. That'll be interesting. Back to math, though. Yes, take the pass. Let's examine. Top of the page. Oscar, could you read for us, please?
Of course.
Thank you.
Let's examine the table to determine the unit rate of change of this situation. One way to determine the unit rate of change is calculate first differences. Recall that first.
You're doing good. Don't listen to them.
Are determined by calculating the difference between successive points.
All right. Thank you. All right, so first differences, they say recall, as if we've done that before. I was trying to think back. I don't remember us doing it, but we can see what they're doing here along the margins of this table. This table is our table repeated. What are they doing as they look from box to box over here on the left-hand side?
1 minus 0. They're subtracting the first variable from the second.
So they're saying 1, take away 0, and then right here they're going 2, take away 1, and then 3, take away 2. They're going to ask us to do the same thing right here on the other side. So they did it for the time, or the independent variable. Now we're going to go 1800 minus 0. What will that be? 1800. Okay, and then how am I going to set up the second unit where I'm looking at these two? What's the subtract?
You subtract 3,600
minus 1,800. Okay, go ahead. Finish. Find that and set up the next box. 30 seconds. Use your calculator. Ready, go.
Yo.
What?
Turn it on. Oscar, get some of these shoes here.
Look, set up right. Now put them into the calculator. Get your answers right here. Look, set up good. What do you get for an answer? Yes. That looks good. What's going to happen there? Thank you. All right. If you can hear me, snap once. If you can hear me, snap twice. Or wave. Okay, good. What did you get in the second box down for an answer, Christian? What? Okay, good. That was nice and quiet. All right. Jackie, what did you set up for a subtraction problem in the third box down? Good. Is that what you got too? Isabel, what did you get for an answer?
1,600. Oh, wait. I thought we were supposed to subtract 1,800 from 1,000.
Oh, good. This, what Jackie has, is what they're looking at. For each box, you're looking at how far apart is one box from the other. So this is 5,400 minus 3,600. This one was 3,600 minus 1,800. Okay, and if we set it up like this, what's the answer? 1,800. Okay, number 8. What do you notice about the first differences in the table. On this side, 1, 1, 1. On this side, what do we have?
1800.
What do you notice?
They're both they're constant.
Ding, ding, ding. Write that down. Answering number 8. They are. Finish the sentence.
Oh, they all equal 1,800.
Okay. They are constant.
Oh.
They all equal. Okay. Another way to determine a unit rate of change is to calculate the unit rate of change between any two ordered pairs and then write each rate with a denominator of 1. Calculate the rate of change between 2 points represented by given ordered pairs in the selection of the table shown. Show your work. Okay, so now this is our table. All right, it's a little bit further down. They've taken numbers in the table and put them in the form of ordered pairs. So this 2.5 and 4,500 came from the first row. This 3 and 5,400 came from the second row. Right? Now, they want us to figure out the overall unit rate of change, and we've been doing subtract, right? But what we focused on was only subtract on one side. This time now, we need to do both sides. Here's how it's going to work. 5,400. Am I getting too low? And I might need to make it bigger. 5,400 minus 4,500 divided by. Okay, where did I get that number? Let's get a couple colors. I got both of those from the second coordinate in the ordered pair, which they got both of those from the table right here. So really what I'm doing is a first difference between these two, but they're showing it to us organized in a different way. Who has an idea what they think is going on the bottom of that fraction?
3 minus 2.5.
Molly?
3 minus 2.5.
3 minus 2.5. The pattern continues, and now we have this rate of change being compared, or we're trying to find the difference or rate of change between those minutes. So on top were these two numbers subtracting. On bottom are these two numbers subtracting, but they look different.
Isn't it 2.5, not 0.25?
Oh yes, thank you. 2.5. Now, when I subtract those two on top, what do we get? 5400 minus 4500. Somebody with a calculator. 900. When I take 3, subtract 2.5. And now what happens if I take that ugly thing and divide through, so I get 1 in the denominator? What happens when you go 900 divided by 0.5? Wait, you guys try it. I don't know if Molly's telling us the truth. Everybody, 900 divided by 0.5. 1,000.
1,800.
Oh, my
No way.
goodness. Oh, all right. All right, you're going to do that for B and C. Try to repeat the pattern of what we did. Mr. Craig and I will be walking around. It's getting tricky, but you've seen the parts. It's just putting a couple of parts together into a simplified format, which is ugly without a calculator, but you have beautiful electronic devices all around you right now, yes? So be careful with your steps, and the calculator will do the work. Here we go. 1 minute, starting now. Setting up the next problem. Yeah, E. Okay. You can, if that's not enough room, do it over here, do it off to the side. There's plenty of space in that book. Setting up the B. You gotta repeat what I did just there. Jackie's on it. She's quiet but on top of things. You might want to make
Are we
friends.
doing C2?
So far, so
Yeah.
good.
Alright, thanks.
Oh, good. That's good. On it.
Okay, why? So right there, we're choosing the
You
graph.
really don't have to be down what I have. So now you're
You said it.
This is right.
And
Maybe it's gonna be right big because we needed more space.
Careful.
It's gonna be on the bottom. What's gonna be on the top? Yes. And subtract.
Yeah.
Very banana white. Don't have maggots in the classroom.
Yes, that's what I mean now. Okay, so you start with this one and take away that.
Just right over there.
You're gonna do the same thing here, so that means you're gonna start with, and go ahead, figure out what the two things are, and then you divide them. I know, they kind of stuck that homework in. It's reminiscent of things you've done in the past. I was like, looking at it, I don't want to do this. I'm like, looking at it, about this one guy.
What is that?
Good. Next one, there we go.
So the
Five are up. Okay. Good, do C. Don't stop now, Christian, keep moving. Do C. Do C. Do C. Nice. Nice. A plus table. What do we got over here? You bringing Wyatt along?
yeah.
Okay, great. This is an A table.
Oh, my team.
Yours
Now
a
you're
J.
gonna do the divide too, okay?
Dude.
Keep going.
Dude, that's before you guys know. Yeah, I did. I gave you something white on
Did you
you.
hear that, Martine?
Yeah, I told them what we were doing.
Let's see how this screws through.
Is that right?
Okay, here's where, see that? You switch from 4 to 5. This is 5, you go 4. You have it set up right, I think you're on
What?
Yeah. You have? You didn't show your work, so I don't know what you did wrong. Back it up, next problem. Anything down to C.
Getting over it.
Okay. Take a look up this way. Here we go. 9,000 minus what?
5,400.
Divided by. Chris? What goes on the bottom of this ratio? 5 minus 3 equals. When we do this subtract, okay, we've got 2 from Brody. That's on the bottom. What's on the top? Yes?
3,600.
3,600. What happens when we divide that?
1,800.
Okay, I already am going to make a prediction what this answer is going to be, but Brian,
1,600.
Brian, what does the top of this fraction look like when I start off? And Myra, what goes on the bottom of this one?
5 minus 2.5.
It looks ugly, but you have a calculator, yes? And you know what? You have been doing math that maybe was simpler math, but it wasn't real life. These numbers are real. This is what a plane does, right? It doesn't go up 10 feet and then we stop to think about it. No, it goes up a lot of feet before we actually think about what's going on. So big numbers, this is part of life. What do we get on top when we subtract?
4,500.
And how about on bottom?
2.5.
And,
1,600.
okay. Okay, number 10. What do we notice?
About the rates and changes.
Yes. What do we notice?
They're all 1800.
Write that down. Number 10. They are all 1800. I don't like 11, and it's not helpful for us. Okay. Number 12. How do the first differences in the rate of change between ordered pairs demonstrate that the situation represents a linear function? What have we seen over and over and over and over again? There was something that keeps popping up.
1800.
Something about 1800. What can we say about that 1800?
Constant.
Is a constant rate of change. And when you have something constant, that's when you get things linear. Okay? If you have it going up one time and down another, you're going to get a positive answer and a negative answer. Did we get positive and negative 1800s? No. We all was 1800. If you have it going up 1800 once and then 300 again, what would that look like for the plane? Doot, 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 doot. And then a little bit lower. Not the same. You know, we'd see a break or a bend or a curve. But because we're seeing the same exact thing all the way along, linear. Constant. Did you write something for number 12?
Yeah.
On your paper, not your brain. You got something written down for number 12? Awesome! All right. I was thinking about moving ahead a little, but I think we'll save problem 2. What I heard around the room is, wait a minute, now I know how to do the homework, yes?
Yes.
There were some of these in the homework. I want you to pull out your homework packet. You can put away your books. I'm going to come around and show you your test scores and grades.
Yeah. So bad.